So in the last two sections, we studied annuity immediate and the annuity due. So basically, those are in the area of level annuities. That means in the next two sections, we will need to study something that are more complicated. Those are varying annuities. The size of the payment may be changing, and how it changes is something we first need to clarify, and then we study one by one. In this section, obviously, we are going to look at increasing annuities. Unlike the yearly payments, again, the frequency would be pthly. They are P payments each year, and here we consider one specific increasing sequence. That is, let me type it here. So here, what we consider in this section, we consider for annuities that that have an increase once per year. So that is the key. Okay, so we're going to see an increase in payments once per year, although there may be more than one payment each year. In a standard setup, we have $1 in year one, $2 in year two, and so on until N dollars in year N. So that is what I meant by increase in payments once a year. So of course, this here we have the payment rate, right? So this is rate, not exactly the actual payments. The actual payments in the first, let's say in the first period would be 1/P. In the second would be still 1/P. Continue on for 1 year, and then in the second year the payments will jump to 2/P, right? So let's draw a graph, because it could be, well, the other case is for each payment there is an increment, right? So the first one is 1/P, the second one is 2/P. It's not in the second year, but here we only deal with the case when we have an increase every year once. Okay, so let's if you look at the payment rate per year, it's $1 in year one, 2 in year two. So you have one increase each year, right? So that's the setup we're going to handle in this section. So it helps a lot when I draw this graph. Then things will become a lot more clear. So again, let's use 1. Here's 2. Goes on for many years. Here's n minus 1. Here's n. So the unit is for years. So the last n means is the end of n years. Okay. Then we know this is 1/P. This is 2/P. Of course, 1 would be P/P. So let me move the position a little to the middle. So 1 would be P/P. So the payment rate in the first year is $1, meaning I will have, here we assume is annuity immediate, okay? So 1/P. This is also 1/P, goes on until the last one. This is also 1/P. So in total, I would have $1. So the first dollar in the first year is equally distributed to P periods. So there will be P payments in year one, each with size 1/P. So then we analyze the same thing. So here would be P plus 1/P P plus 2 over P, etc. goes all the way to 2P over P. That's 2. But in the second year, the payment becomes 2 over P, right? So previously it was 1 over P. That means in the second year, the payment rate would be 2. Right? So you can easily do the analysis. So here I know the amount would be 1 over P, 1 over P, okay, N dollars. If you want to look at a different scale of time unit, that would be 0, 1. This one means the first period, so the second period, 3 all the way to P. And then you have P plus 1, is P plus 2, goes all the way to MP. So here is each period. Okay, 1 period equals 1 over P number of years. So that is the conversion. Okay. But in general, I don't use this part. That's because our convention is always to express time in the number of years, but it does not have to be the case. It's just our convention. Okay, we normally when we draw the timeline 1, 2, 3, those refers to years instead of individual period, which can be 1 month, can be 1 quarter, can be anything you prefer. This is a standard, what do we call the increasing pthly annuity immediate, right? It is annuity immediate because all the payments are made at the end of the corresponding period. So at the end, that's why it's annuity immediate. It's pthly because there are P payments each year. It is increasing because from year to year, the rate of payment goes up by 1. That explains all the names down here. Let's put a notation. So obviously we first look at the present value, and the notation we use is IA. Again, I stands for increasing, A stands for the present value. Because this is a pthly, so I write upper P. Since I have n years in total, so that's my notation. It is read as I A upper P angle n. So this is how you can pronounce this notation. Obviously, it is a present value, so it will be the value at time 0. Right, so it will be at this point. Okay. Of course, the standard way of analyzing is draw the timeline, which we already did, analyzing the payments, which we already did, and then we should write down everything nicely, one by one, okay, in a complete sequence. The first payment is 1 over P. I discount by 1 over P. The second payment is also 1 over P, but it's paid at 2 over P. So I have to make the adjustment for discounting. So you already know what is the last one in year 1. So it's actually P over P. So this is all the payments in the first year. So this is the P, the present value of P payments in year 1. Okay, so we can continue to do year 2. For year 2, the size of the payment is 2 over P. And it's P plus 1 divided by P. So what you can think of is, so what we can think of is is 1 plus 1 over p, okay, because it's the second year. So you have to let 1 year pass by and then discount correspondingly for what you have. Right, so this is the present value of p payments in year 2, right? And then, of course, we know how to continue. We do everything the same until I get to the very last year, in which my payment would be n divided by p. So here would be n minus 1 plus 1 over p plus n divided by p, v to n minus 1 plus 2 over p, goes on until the last payment, which is n minus 1 plus p over p, so it's actually n. So this is the payments in year n. So this year. Okay, there are many things you can do, right? So here we observe something. So what we can observe is the first bracket. So this guy, it's somehow interesting, right? We can fact out this. Then the first one becomes 1. The second one becomes 2 times v, right? Because 2 comes from here and v comes from everything is 1 plus the corresponding term. Okay, then you easily see last one would be this, right? So that's I can achieve this equality because I simply fact out all the common factor, right? That's the reason why I can write as in this way, right? If you pay attention to the power, right? Let me get a different cover. Let me get a different color to cycle. So here's 1 over p, 2 over p, 3 over p goes over to p over p. So you see here, the same, right? It's repeating. So I just need to factor out this part, right? Then that's what I will get, right? It's here, and n, right, come from there. Okay, with that in mind, we can start to identify what we have. So this guy becomes, what is this? If you can't see, let's factor out 1 over p, right? Then it becomes from there we can already know. If you factor out 1 over p, what you can see is this is exactly what we just started, right? It's a standard annuity immediate with pthly payments, and the payment is actually 1 for 1 year. So that's why here it's angle 1 because I only want it for 1 year. And the second one, this is a standard increasing annuity due because the first payment is 1 for n years, right? Because it goes from 1 is v to the power of 0, 0 to n minus 1. There are n terms. So this n means the number of payments is n. Okay, so we know how the formula for each of them. So we can apply the formulas we know to get the result. For instance, the first one would be 1 minus v, n is 1, so let's write 1. Okay, IP times, here is annuity immediate, n minus n en divided by d. Okay, so now we can work a little to simplify. That's because remember d equals 1 minus v, right? So using this, we can cancel these two. Okay, then we get the result. So let me put it in a nice box. So this would be the present value of increasing annuity immediate paid P times a year. So put interest rate. So this is obviously the effective interest rate minus n v to the nth divided by I upper P. I would say this is not a surprising formula, right? Even you don't do any mathematics, that would be the reasonable result you should be able to guess, because if you look at the standard result down here, right, the numerator is exactly the same. So what will change is pretty much the denominator, right? As I always say, if you really want to memorize, this is annuity immediate, right? So you are going to divide it by I, and because this is a pthly, the payment is made P times a year, so you divide it by I upper P, right? And here you divide it by D is because it is an increasing annuity due, right? Due you divide it by D, right? So later on, if I ask you what would be the present value of increasing pthly annuity due, we just need to change this I upper P to D upper P, right? Even I don't do anything, I could make that guess, and later on you will see that the guess is actually correct. So that's the mathematics behind it. So I did all the mathematics, and again, using the trick from the textbook, you can actually easily memorize. Once you know one, the rest is the same, right? You just need to make corresponding changes to the denominator, right? So here it's annuity immediate, so you divide it by I upper P. So let's do a quick example. 4.18. Determine the present value. So we're going to apply this result of $1 at the end of each quarter, 2 at the end of each quarter in the second year, 3 at the end of each quarter for the third year. Okay, so now we have a standard case. It's just the number is slightly different. So let me draw a quick graph. So this lasts for 5 years. Okay, in the first year, it's paid every quarter. So I have 1, 2, 3, 4. At the end of each quarter, the payment is $1. The payment is $1. Here is $1. Here's $1. So which means in first year, I will actually get $4, right? And then moving on to the second year, first quarter, second quarter, third quarter, fourth quarter, now is $2. So meaning in the second year, I'm expected to get a payment rate of $8. See, this is slightly different from our setup, right? If you go back to the setup, is $1 in year 1, $2 in year 2. Now what we have is $4 in year 1, $8 in year 2. Then you would expect $12 in year 3, right? So it's basically you're going to factor out $4. So that's that means you are going to factor out this factor 4 is because it goes from 4, 8, 12, 16, 20, right? Instead of 1, 2, 3, 4, 5. So you factor 4, then that is an increasing annuity immediate. So I don't need to put double dots. There are 4 payments a year because of it's a quarterly. They are 5 years in total. So this is everything I have. Okay. By the previous formula, this would be the annuity due 5 minus n is 5 v to the 5th divided by I4. Okay. Now I know I is 4%. So if I is 4%, V is going to be 1 divided by 1.04. So that's easy to work out. And I4 is also easy to study, right? So we know I4 equals 4 times 1 plus I, 1 over 4 minus 1. Right? So you can calculate the result from here. And annuity due, by the way, this you can directly get from your financial calculator. But anyway, this would be 1 minus Vn divided by D, right? Again, 1 minus V to the nth is the same, right? Because this is annuity due, so we divided by D. D will be I over 1 plus I, right? So by now I have all the ingredients, right? So the annuity due is given by this. I know V from here, and I know I alpha 4 from here. Finally, you should be able to plug in to get all the results. But of course, remember to multiply by 4 to get the final result. That is for the annuity immediate, right? The next one is to study annuity due. So we study increasing pthly annuity due. Okay, everything is the same except now, well, the payments are moved forward by 1 period. So now if I quickly draw the graph, okay, I don't spend that much time. So it's still, you separate it into each period, goes on, but now the first payment is at 0. So here, 1 over P. So here you get $1, okay? And then starting at time 1, it becomes 2 over P, becomes 2 over P, goes on until the last period in year 2. This is 2, right? Goes on for the last one. This is N minus P. This is N divided by P, not minus. N over P. So this would be $N in the last year, right? So if I ask you to write, first of all, let's write the notation. So it's the same except here I'm going to put double dots. So IA double dot upper P angle N. It would be 1 over P plus 1 over P V 1 over P 1 over P. Well, this P minus 1 times P. So this is the first year, right? And then the second year is this. Let me continue how I write previously. It's 1 plus 1 plus 1 over P 0 over P plus 2 over P V 1 plus 1 over P goes all the way to 2 divided by P V 1 plus P minus 1. Okay, and it goes on until the very last one. So this will be N minus 1 plus 0. N minus 1 plus 1 over P. N plus P minus 1 divided by P. Okay, so you know what you need to factor out, right? So it's obviously the first one is going to is what you need to factor out. If you do that, what you will get is what you will receive is annuity due, and then you're going to times by the same thing. It's 1 plus here would be 2V plus 3V squared, right? So this this part would be the same as here, right? So that part is the same. So it's IA. Okay, so pretty much everything is the same except now it would be 1 over V divided by D upper P. So here you get the same formula, minus N Vn divided by D. So this D will cancel this 1 minus P. So you will get I A double dot upper P angle N. If you want, you can put the effective interest rate. Right? Just as what I claimed, now you just need to divide it by D upper P. Right? So of course we handle the present value. Future value, it's exactly the same thing. For instance, what would be the future value? So the notation would be IS upper P angle N. This would be, right, this is obvious, right? So once you do the results, you'll get this becomes the accumulated value of an annuity due minus N, and then I will need to divide by IP. Okay, so with this in mind, well, you immediately anticipate this result. IS double dot P angle N. Okay, so obviously this is 1 plus I to the nth times I double dot A, IA double dot upper P angle N. This would be the future value. So it will be it's the same as what we have before. It's just that you divide by D upper P. So we are in the same area. It's just that there will be a little difference in some fine tuning. Let's do an example. Okay. Determine the present value of 10 at the start of each quarter in the first year. So we know. So I directly draw the graph. So it will be 10 in each quarter. So 1, 2, 3, 4. So here I have 10. Here I have 10. I have 10. So in the first year I have 20. I have $40. And then in the second year, 1, 2, 3, 4. So I have 20, 20, 20, 20. Okay. So obviously this is a annuity due because all the payments are at the beginning of each quarter, and so on for 5 years. So which means in the last year it's 50, 50, 50, 50. Okay. The annual effective interest rate is 4%. So this is all the information we have, and we want to know the present value. Then all we need to do is to compare with what we studied, right? To see what would be the difference. What would be the difference? The difference is in the standard setup, I get $1 in the first year. Okay, here I get actually $40 in the first year. So I will factor out this 40. Then I can use the notation I just introduced. That is IA double dot. It's quarterly payment, so which means P is 4. I have 5 years, so angle 5 at I, right? So according to this formula, it's 40 times A double dot angle 5 at I minus 5V to the fifth divided by D upper 4, right? Okay, this annuity due, you can actually use your calculator, but of course we can easily compute. This is simply 1 and divided by D because again this is annuity due, it's a level annuity due, so it's 1 minus 1.04 to negative 5. This is I divided by 1 plus I. So complete this result. So we have we know the first thing. We already know, right? So V fifth is this to negative 5. Okay, so we know the second one. We just need to know one thing is D4 is 4 times 1 minus 1.04 negative 1 over 4. So this is how we calculate the nominal rate of discount. So it works pretty much the same way, you know, for the discount as what we did in 1 year. So let me recap what is the meaning of D. Okay, because that is often the confusion part. So by the way, we already finished this section, right? According to the textbook, yes. Of course, from here you can also calculate the future value. So once you know the present value, you can easily calculate the future value. Okay, all you need to do is times by 1 plus I to the nth, and here our I is 4%, so it's 1.04 to the fifth will give you the accumulated value. So we use the rest time of this lecture to briefly recap what is the meaning of D. Okay, so let's begin with the original setup. Is for 1 year. So let me put the time down here. Time 0, time 1. So assume right now 1 is 1 year. Okay, so start with $1. I will receive 1 plus I, right? So 1 is the principal, I is the interest, right? So I'm going to decompose 1 plus I into 2 parts. Okay, so now let's draw this. Well, this is trivial, right? 1 plus I, of course, equals 1 plus I. So if we go both ways, 1 at time 1 would be equal to V at time 0, right? That's how you do discounting, right? V at time 0 will grow to 1 at time 1. So the question is here, right? How much is it worth at time 0 to have I dollars at time 1? So this is what we call D. So from that, we know D is the present value of the interest at time 1. That is the reason why D equals the value divided by discounting, right? And from here, we can also see those two adding together should be 1. That's why D is also 1 minus V. So that's why we often say 1 minus D is the effective loan. So here the meaning of effective loan is you want to borrow $1 from a bank. So that is your original purpose. Your purpose is to borrow $1. So $1 is your nominal goal. You are trying to get $1. But since the bank asks you to pay the interest up front, So your cost is not paid at time 1, because if it's paid at time 1, you pay 1 plus I, but you get $1 at time 0. Okay, so let's change the story. The bank does not want you to pay the interest at the maturity. They want you to pay the cost up front. Okay, that is also common. Well, sometimes we call this down payment. Right, down payment is obviously usually a lot more than your monthly installment. Like I say, when you get a car loan, you might need to put down a few thousand as down payment. Right, that's the cost. That is the cost to secure this loan. So it makes perfect sense for the bank to charge you fees up front for the service you haven't received yet. So right now, I assume you have walked into a bank trying to borrow $1, but since the manager has no record of your credit, so he asks you to pay the cost upfront, and the cost upfront is not I. I is the cost at time 1. The cost upfront would be D, which equals I divided by 1 plus I. So after paying this cost, what you can get from the bank is 1 minus D, right? So that's why we call it the effective loan. You are trying to borrow 1. 1 is the nominal loan, okay? But you don't walk out from the bank with $1 in your pocket. Instead, you only have 1 minus D in your pocket because you have already used D dollars to prepay the cost of borrowing $1 for 1 year. So that is the complete story of discount, right? So from that, we can, all we need to do is to move the time unit. Here's time 0. This is not 1 year, this is 1 period, meaning it would be 1 over P number of years, right? So we know everything is still the same. So if I break this 1 into the 2 parts, okay, this would be my D upper P divided by P, right? So this would be my upfront cost, okay? This, of course, it will be 1 minus it, but we don't care about it. What we care is essentially this guy, because one thing I should mention from here is 1 minus D. Do I have space? So let me write here, because that is what really matters. So after that, we know because 1 minus D is V. So 1 minus D at time 0 will grow to 1, right? That's obvious, right? Okay, so using the same idea, so 1 minus this should go to 1. Okay, so that's the basic idea of rate of discount, right? So once you have that in mind, and if you have $1 down here, and if you apply the discounting, what would be the value? So we know this would be, we discount back by 1 over P period of time, right? And that means it would be 1 minus D discounted by 1 over P amount of time. So that is everything you have now, right? You can, of course, here you have I, so it will be 1 plus I to negative 1 over P, right? So let me conclude here for this video, and we're going to start a new section. We have 1 section left of this chapter.